I'm going to go through everything you need to cover straight line graphs in just 10 minutes. The most important thing you guys need to know is the equation of a straight line. And now that equation is y equals mx plus c, where m is equal to the gradient of the line and c is equal to the y-intercept, meaning the point where the line crosses the y-axis. The gradient is the slope of the line, so it tells you how steep the line is. To calculate the gradient, you need 2 points on your line, and from there you're going to do the change in y over change in x. You can see on the graph here we have point B with coordinates x2, y2, and point A with coordinates x1, y1. So the gradient would be equal to y2 minus y1 divided by x2 minus x1. There are two ways we can write down the equation of a straight line. Those are y equals mx plus c and ax plus by plus c is equal to 0, where a, b and c are all real numbers. Let's now take a look at example 1 where we have to calculate the gradient of this line. To start with, I'm first going to write down the two coordinates that we know. We're given coordinate A as 4, 3 and coordinate B as 7, 5. In maths terms, we write gradient as the letter m, and now m is equal to the change in y over change in x. To start with, let's take the y coordinate of B, which is 5, and the y coordinate of A, which is 3, and we have to subtract them. So we write down 5 minus 3. For our change in x, we do the same thing, but with our x coordinates. So we'll have 7 minus 4. Now you just carry out the calculation and we should get 2 over 3. Moving on to example 2 where we need to find the equation of the line in the form ax plus by plus c is equal to 0. First I'm going to write down the information that the question has given us. They tell us that the gradient is equal to 2 and the y-intercept is equal to 0 minus 7. With this information we can sub this into our equation of a straight line, which is y equals mx plus c. Now m in this case is equal to 2 and our y-intercept c is equal to minus 7. Subbing in our values gets us y equals 2x minus 7. But we're not done there. Now we have to write it in the form the question wants, which is ax plus by plus c. To do that, we bring all of our terms to one side of the equation, which I'm going to do now. And we get y minus 2x plus 7 is equal to 0. So a is 1, b is minus 2, and c is 7. You now know the basics, but there's a quicker way that we can work out these kind of questions. And that's by using the formula y minus y1 is equal to m bracket x minus x1. To break this formula down, we only need to input y1, x1 and m, and we can rearrange to get the equation of the line, where y1 and x1 are coordinates on our straight line. Let's now try and tackle example number 3 using our new formula. We have to find the equation of a line that passes through points 7, 2 and 8, 5. Of course, our first step is to find the gradient. We always must do this first. Subbing in our coordinates into the change in y over change in x gives us a final answer of 3 for our gradient. Now that we know our m value, we can sub this into our equation. Of course, for y1 and x1, we have to pick one coordinate and use them two values. So in this case, we'll take the coordinate 7, 2. So y1 is equal to 2 and x1 is equal to 7. After rearranging, we get y equals 3x minus 19. See how quickly that solved our question instead of doing all of the steps before. Now let's move on to parallel and perpendicular lines. The key definitions we need to know are that parallel lines have the same gradient because their slope is the same, and perpendicular lines are normal to each other. Now normal means they intersect at 90-degree angles. If we take a look at our first graph, we have two parallel lines, y equals 2x plus 2 and y equals 2x. You can see our m value of 2 is the same for both. That's how we know that they're parallel. Looking at our second line, there's a trick we need to know to figure out whether lines are perpendicular or not. Thus, the gradient has to be the negative reciprocal. What I mean by negative reciprocal is, let's say we have 2 as our gradient. We have to put that as a fraction as 1 over, so we'll get 1 over 2. And then to get the negative, we put a minus sign in front. So instead of 2, the gradient should be minus a half. As you can see with these two lines, one of them has a gradient of 2 and the other has one of minus a half, so they're perpendicular. Moving on to example 4, where we have to find the equation of line L1. Now they tell us that L1 is perpendicular to another line, and that line has the equation y equals minus 2/3 x plus 4. Remember guys, our first step is always to find the gradient of the line that we're looking for. In this case, the gradient of line L1 should be equal to the negative reciprocal of the line they've given us. The gradient of the line they've given us is minus 2/3. Now to get the negative reciprocal, let's first look at just the reciprocal, which we have to flip the fraction over. So instead of 2/3, it's 3/2. Then we can add the negative part in. So instead of a minus of a minus is a plus. So our new gradient is 3/2. We have m now, and we have a coordinate 4, 6. So we can plug these values into our equation for a straight line. You can see that first I subbed in the values, and then I rearranged the equation, and we get y equals 3/2x. The final part of this chapter is to find the distance between 2 points, and then we can use that distance to then find the areas. There's only one key formula you need for this part, and that's what I've highlighted, as you can see. So the unknowns we have are d, which is the distance we're trying to find out. We have x1, x2, and y1, y2, which are coordinates that we're going to put in. In example 5, we're given two lines which are perpendicular to each other. Now we have to find the point in which they intersect and the area between them. Let's start with the intersection of both lines. To find that out, we equate our equations together. So we're equating minus a half x plus 2 is equal to 2x. From here we rearrange to get our value of x, and then we can find our point y by subbing that back in. After rearranging, I get a value for x that's equal to 4/5, and then I can sub that point back into any line that I pick. So I pick the easier one, which is y equals 2x, and I get a value of y equals 8/5. If you now look at the graph that's drawn on the right, you can see that we've got both of our lines and that it forms a triangle with our y-axis. That triangle is triangle ABO, and we have to find that area. The trick here is, since they're perpendicular lines, we have a 90-degree angle in our triangle. So therefore it's a right angle triangle. Our first step from here is to now find the length of the sides of our triangle, which we can use our new formula. Starting first with side AB, you can see I've plugged in the coordinates of B and A into our formula. Then you just plug that into your calculator, and that'll give you an answer of 2√5/5. Let's now do the same thing for length OB, and again for this I've plugged in point B and the origin, which is just 0, 0. And we get 4√5/5. Hence, the area of our triangle ABO is equal to half of the length of AB times by the length of OB, which works out to be just half times 2√5/5 times by 4√5/5, and that gives us our final answer of 4/5, or 0.8. That's really all that you guys need to answer any type of distance related graph question. You've now made it to the end of the video guys. I hope you found that useful, and if you did, make sure to drop a like down below and let me know which topics you want me to cover next, and I'll make a video on that too guys. Anyways, that's all from me, and I'll see you guys next time.